our CEO of Huji Innovate. So it's at 5:01 and I would like to start. I want to welcome you all for this international webinar. We're hosting together with ICL Corporation, together with the Huji Innovate, the Center of Entrepreneurship of the Hebrew University, and the Faculty of Agriculture, Food and Environment, also from the Hebrew University. A few sets of rules. I will define everybody to be on mute except for our speakers. They will talk, and then we have a few scheduled times for all of us to ask questions, and you're more than welcome to write it on chat, and I will be opening those questions and forwarding them to the speakers. My name is Yotam Zach, and I'm the community manager of Huji Innovate, and I welcome you again, and thank you for participating. So without further ado, I'd like to welcome our CEO of Huji Innovate from the Hebrew University, Dr. Amnon Dekel.
Thank you, Yotam. Hello, everybody. I'm going to say a few things about Huji Innovate, so I'm going to share my screen for a few minutes, and then we can get on with the show. So we are Huji Innovate. Yotam, we can see, everyone can see? Just want to make sure.
Yes.
Okay, thank you. So we're Huji Innovate, the Hebrew University platform to encourage and assist our students, our faculty, by the way, our research and also our admin faculty, and our alumni to develop their innovation and entrepreneurship capabilities. We do this utilizing a model that we built that we call Inspire, Learn, Build, Lab, and then collaborations and partnerships. So I'm going to take a minute and a half to talk about these. So Inspire basically is our first floor in the system, where we basically mix entrepreneurial culture, community, and experience. So we have meetups, events, workshops. You're part of this happening right now. Campus communities, digital communities. We also run hackathons. We just finished a great competition yesterday called The Morning After. And we run a yearly Creativity Cup for our students. On the Learn phase, we have a mixture of entrepreneurship workshops and existing courses around the university. We do extracurricular entrepreneurship courses. We do entrepreneurship courses for high school students, and we also do our TIP International program, as you can see here. In the build phase, we have what we call our open venture creation studios, and the studios are focused around a number of different key verticals. So we have one in the ag food space, one in the health space, one in social space, and we also have what we call the X space, which is a mixture of technology-enabled or research-enabled entrepreneurship. And by being as part of these programs, all our participants get hands-on workshops and lectures. They get to meet mentors and experts from around the world. We connect them to the world ecosystem, and they also are able to work in our co-working space at the university. We also have Startup Sunday, which is a program of webinars for people who are interested in various things. And we also have what we call office hours. So anybody in the community who wants to sign up for office hours with anyone on our team can go to our website and sign up. We take quite a few of these every week for different things. So feel free to be in touch with us. We're on Facebook, we're on Instagram, we're on LinkedIn, and of course on our website at Innovate Huji, ACIL. So thank you very much. And I'm looking forward to hearing the interesting things that we're going to be doing and hearing today. Thank you, Yotam.
Thank you, Amnon. And now we'll be more than happy to welcome Dr. Disking. Thank you.
If my internet connection is unstable, Zeev or somebody else can take over. So again, good morning, good afternoon, good evening to all of you, depending on where you are. Shalom. My name is Ananta Desikan. I am the Chief Technical Officer for ICL Group. I'm joining you today from beautiful Westchester County in New York. It's a suburb of New York City. I know Israel is almost back to normal, and we are slowly getting back to normalcy in New York. At least some things are opening up, and I hope it's the same for all of you across the world. So I would like to first thank Yotam Zach for giving us this opportunity to host this virtual meetup, as we call it. Also to Mr. Itai Green of Innovate Israel for helping us coordinate this with Yotam. And also Dr. Amnon for giving us this opportunity and also for this great introduction, actually, that you provided. So thank you very much for that. And also thank you to all of you who are joining us from across the globe. I think we are really excited to be presenting a background on ICL, our innovation approach, and also the opportunities for collaboration. To start with, I would like to provide some background on ICL and our innovation approach, and my colleagues will then join in to talk about crop nutrition, food, energy, and materials, innovation around food, energy, and materials. And over the last few years, we have established several partnerships with academia and startups globally, and it's our intention to further strengthen our external partnerships. So that is our intent today, to kind of communicate that activity as well. So ICL Group, headquartered in Tel Aviv, is a global specialty minerals and specialty chemicals company operating bromine, potash, and phosphate mineral value chains in a unique integrated business model. ICL, as many of you know, extracts raw materials globally from well-positioned mineral assets and utilizes technology and our know-how to add value to customers in key agriculture and industrial markets worldwide. We had sales of about 5.3 billion in 2019 and have leading positions in our target markets. As you can see, we are globally positioned. And our low-cost production processes. We have unique assets with proximity to our customers, and we have optimized our supply chain solutions to leverage this further. And we constantly strive to use our know-how, formulations know-how, industrial know-how, and also our agronomy know-how to solve customer unmet needs. And as you can imagine, as an Israel-based company, one of our key strategic advantages is our access to the ecosystem of the startup nation. So this is something that is, we think, is a very strategic advantage. We are leveraging global ecosystems, but I think just being in the home of the startup nation is very important, a strategic advantage for us. So I just wanted to quickly present our 4 business divisions. Industrial products, we are the world's largest producer of bromine and bromine derivatives. Avi is going to talk about this a little bit later. Bromine and brominated products are used in a variety of applications. Our phosphate division is an integrated mineral chain. I call it almost from rock to fork. So we mine the rock, and we have food applications that Andreas is going to talk about. Our innovative agro solutions business is where we are taking specialty fertilizers and where we have controlled release fertilizers, water soluble fertilizers, and specialty fertilizers, other specialty products, basically crop nutrition products. And then the potash division, which produces potash, which is a key fertilizer, and also produces polysulfate, which is a unique raw material that we have for crop nutrition, and we are globally positioned there as well. So the innovation at ICL, I just wanted to give you a snapshot. We spent about $61 million in 2019. Average is our 60 to 65 million is our average spend. We have 250 colleagues worldwide focused on R&D and innovation. 20 R&D centers globally. Again, strategically positioned to serve customer needs. Over the last few years, I'm happy to say that we had many contacts, but we've initiated 40 external innovation projects. A few of them have come into the business, and 2 of them are in the late stages of commercialization. And we have a patent portfolio of about 850 granted patents which comprise of about 250 patent families. So this is a quick overview of our innovation. We focus on identifying new applications for our minerals, products and formulations, process efficiency, and developing new technologies, as you will hear also later. So I think I just wanted to spend 2 minutes about what is our kind of a core of our innovation. We want to be market and customer centered. So we constantly strive to understand unmet needs in the market, unmet needs of our customers before we develop solutions. As you know, that innovation is not only invention. So it's important to understand these things. We want to connect our internal and external ecosystems, nurturing innovative culture, executing projects, and building a robust pipeline of projects. And again, this is again one of the reasons why we are engaging with our external ecosystems. So this is a key part of our thought process in terms of innovation at ICL. So any talk on innovation does, has to have a slide on mega trends, as you know. So I have one too, right? So these are what we think are the main mega trends that are impacting our business. Now, this is pre-COVID. So as you can imagine, many things are changing because of the pandemic, and we are not sure how those changes will affect these mega trends. I cannot say today that I know the future, so I did not change it. So this is a pre-COVID slide, but I believe that most of these mega trends will remain and will influence our business, and some of them will strengthen, some of them will change. So, but I think I believe after looking at it again, so, these mega trends will definitely influence our business. On top of these mega trends, I'm not going to talk about it today. We are also using the United Nations Sustainability Development Goals as a kind of our guiding principles for our innovation. So we've developed quite a bit of process around it. We have in our website, we have information around it. I'll be happy to share this with you if anybody is interested, how we link this to the United Nations Sustainability Goals, which is quite important, I think, for society at large. So the question then becomes, how do you translate these mega trends to innovation domains or ICL's innovation intent? It's complicated, and I think what these mega trends give is, people call them as challenges or wicked problems, right? Like they create wicked problems, and these wicked problems also create great opportunities, I think. And so we are developing our innovation intent by starting to imagine the future and understanding our core competencies, strategic advantages, as I mentioned earlier, identifying gaps that address this future product, business, or scenario that we have imagined, and then leveraging the external ecosystems to create our innovation intent in a particular area. And today, after all this, I think we have 4 innovation domains in food, agriculture, mainly in crop nutrition, energy, and materials. And we'll talk about this, during the course of this meetup. So this is a complicated slide. I just learned, I have some scribblings here. I know it's not, I don't know whether you see that, but it's, but anyway, so this is a complicated slide. I just learned to do a starburst diagram in Excel last week. So I've used it a lot. So this is basically talking about our business being split into commodity and specialty. And, our R&D spending is also based on that. If you can, commodity business has a different type of R&D spending. Our specialty business has a different spending. We have core innovation in our 4 divisions. I have 5 listed here because our phosphate specialty business has its own innovation program. Andreas will talk about it. Each of the businesses doing further on their new business development activities and breakthrough opportunities close to the core. The commodity businesses are innovating quite actively in the areas of operational excellence, where they're leveraging Industry 4.0 to enable this. Here in the Industry 4.0 and operational excellence, we are quite actively engaged with the Israeli ecosystem to bring these technologies into ICL. And we have created some lighthouse projects actually to understand really the future of Industry 4.0 in our operations. And then our vision, overall vision for our open innovation and external innovation program is to serve as an innovation accelerator to all our divisions and also create new opportunities and businesses for ICL. You can see in the open innovation, we have an ongoing program, what we call ICL Innovation. I'll talk in the next slide briefly. We have our corporate R&D lab in Haifa called TAMI, which acts as an accelerator and incubator of sorts. It engages with the external ecosystem quite actively today. We are starting to get engaged with external accelerators and external incubators to establish collaboration opportunities. And we are thinking about starting accelerators on our own as well, as we are in the planning stages of thinking of doing acceleration and incubation on our own. So this is hopefully providing you our ecosystem of innovation here. And again, as I mentioned, food, crop, energy, and materials are important. We're also looking at digital agriculture, and we've made some investments understanding how can we participate in the digital agriculture space, trying to leverage our agronomy know-how, and other of our crop nutrition know-how, and go and access farmers directly. And so this is just a kind of ecosystem engagement model that we use today. And you can see that we start with understanding our unmet needs internally, engage externally, and select candidate solutions, work with the business units, and then we have licensed products and bring solutions inside. Today, we have about 55 partnerships under evaluations with startups and academia. We have 15 active partnerships going on. As I mentioned to you earlier, 2 products under commercialization. And at the bottom, I give you a flavor of the partnerships that are ongoing actively, and we've worked with some of them in the past as well. So again, the goal is to expand this partnership, provide some, I just wanted to give you some flavor of how we engage with the external ecosystem today. And of course, we are not perfect at it. So we always are looking for ways to improve it and do things better. And so again, great opportunity for us to do this today. So again, thank you for this. Again, my name is Ananta Desikan. You can connect with me. I'd love to connect with all of you. You can email me or connect with me on LinkedIn. We also have our websites listed here, and if you want to take a look at our businesses and get some further information. Thank you very much, Yotam.
Thank you, Dr. Diskin. I would like to ask, please, if someone that is interrupting through the presentation to please stop it. It's really interrupting us to go through the webinar. Thank you. Next up, we have Ziv Korem. Ziv Kohav, my mistake. The manager of internal innovation of ICL Group in Israel.
Thank you. Okay, let's share this. You see this okay?
Yeah, we can see it, Ziv. Thank you.
Okay, perfect. Yes, I'm Ziv Kohav, manager of external innovation in Ananta's team, and Robert, who's also on this on the line. So I'm going to speak about some challenges in the ag space that we are dealing with. More so the challenges that we see in the future, and not so much the products that we currently do, but I'll give a few words on what we do today. Okay, so we are mainly in advanced crop nutrition. So obviously fertilizers is part of it, but if you look at the trends that kind of affect society that Ananta spoke about before, you see that fertilizers alone cannot really address all of the needs that come out of the overlap of those trends. You see the diminishing arable land, the growing population, urbanization, the strengthening or the stricter regulation, and the forces that come from, from environmental concerns. All of these really bring to the realization that fertilizers alone will just not cut it, and you really need to think about solutions that are more advanced. So who we are today in terms of fertilizers and in terms of crop nutrition. So we're number one globally in soluble phosphate-based fertilizers. We're number one in Western Europe and in compound PK fertilizers. And we're the third most competitive globally in potash production. The potash division actually brings us $1.5 billion. So that's a substantial part of our revenues come from this. And the innovative ag solutions or the specialty fertilizers, this is another $0.7 billion. I'm mainly noting this so you know, if you do want to collaborate with us, you know that we are in a way sufficiently big to be able to commercialize products that you may think of or technologies that you may think of. So you can see some more data here on this screen to do with the quantities, but in general the message is, you know, we are strong in the market, we are a leader in specialty fertilizers, we are a leader in a number of areas to do with crop nutrition. I want to link it a bit to the COVID-19 situation that we all face. So one of the realizations that we had from it is that, you know, the community support is really, really important, and sharing the information, sharing the knowledge. And so something that was in the plan for a long time, this was a good timing to launch it, and it's called AgroPro. And you're very welcome to look at this later. Just search for AgroPro in the internet, and you'll find there a wealth of information, agronomic information mainly, that you can tap into and you can participate. So that's just one response that we had to COVID-19. And in general, we are developing our digital capabilities to do with agriculture and agronomic knowledge. And so, you know, expect to see more from us in the near future about this. So if we talked before about the trends that affect every one of us, those trends bring us to, as I said, to the realization that traditional fertilizers can no longer cut it just on their own. And so although they are still the lion's share of, you know, the ag market, you are starting to see a rise in all kinds of specialty fertilizers, in biosolutions, in you know, fertilizers that are more to do with the micronutrients that are inside them. And all of those specialty solutions are things that we are playing part in, and we are bringing solutions already now. If you know some of our brands like Osmocote that has been around for a long time, this is dealing with controlled release fertilizers, you know, much before precision agriculture was a hot topic, and it is certainly something that provides nutrition to the plant in a very accurate way. So you can certainly relate this to precision agriculture. So we are looking at all those different solutions, and now more and more we're also looking at biological solutions that perhaps in the past we were not so much, and we have already products in the market, and we will have more. Okay, so I want to focus on challenges, right? So I listed here a few of the challenges. You can actually see all of the challenges and the real good level of detail on those different challenges on our website that I'm going to put on the last slide. But if you want to have a look at it, it's icl-innovation.com, and each of the needs have a page there. You can see it. So I'm going to speak about nitrogen fixation for crops, about effective delivery systems for plant actives, plant stimulants. I'm going to mention increased nutrient use efficiency, and give one example of this on the phosphate use efficiency. And I'll speak about biodegradable coating for controlled release fertilizers. I will not speak about the last two, but you can find them on the website that I mentioned before. Right, okay, so nitrogen fixation. So the thing here is that Well, from our side, we are not a nitrogen manufacturer, right? So we don't have our own source of nitrogen. So this is like our motivation to go into nitrogen fixation. But really, there are many motivations there. Nature has been fixing nitrogen from the biggest reservoir of nitrogen, which is the atmosphere, for millennia. And so nothing new there. But this is sort of limited, to legumes. It's limited to only specific crops. And when you think about the row crops, and you think about all the different crops that are out there, they cannot do without urea or without some sort of nitrogen source in one way or the other. But there is a move now to see if some of the nitrogen supply could come from nature, so or from other means. So you could look at biological solutions like endophytes, right, that fix nitrogen and make some of it available to the plant in some sort of a symbiotic process there, or coexistence. You can look at materials that can, in a photocatalytic way, can fix nitrogen, take nitrogen from the air and react it to produce ammonia. You could look at other ways of making this nitrogen available to the plant. You could even look at processes that are now developing in the world to replace the Haber-Bosch process to produce to fix nitrogen and to produce ammonia. So all of those things are of interest to us, because they present a host of advantages. First of all, it presents the ecological advantage, because, as you probably know, those of you in this field, much of the nitrogen is being lost, leached, and there's a lot of wastage there. There's a lot of pollution there. So if you could give nitrogen in a much more accurate way to the plant, you really benefit here, and the environment benefits in here. You also save money, if you can be more accurate with the nitrogen input that you give there. So you look around and you see that I mentioned endophytes. So some trees do it. Again, evolution brought them to this. So we are in this process of trying to find those solutions that are either biological or that somehow introduce or somehow help the bacteria or the fungi that are doing this fixation, or that in other way provide some of the nitrogen to the plant. You can see here some of the numbers, and you will see it on the webpage as well, that are our criteria in this specific need. But in general, any innovation that you have around this need, we would be very, very happy to look at it together with you and see if some new product can come out of it. So the second need I'm going to speak about is the delivery systems for bioactives. So the thing behind here is that there are many known materials and compounds that do some beneficial thing for the plant. So they can increase yield, they can improve the nutrient use efficiency, they can do all kinds of things. But because the delivery system in the plant is such that blocks out different compounds, because the plant needs to protect itself, those materials that we know can be beneficial don't end up in the organelles that they need to reach. So you take some known biostimulant as an example. It doesn't pass the cuticle, and if it does pass the cuticle, it doesn't go through the phloem, and if it does go through the phloem, it gets stuck in the cell wall, which is the main thing that differentiates between mammalian cells and plant cells, and so it sort of blocks everything out. So we are looking at a sort of solution that could deliver either organic molecules or even some of the nutrients which are inorganic in a way that would go through all of those barriers in the plant, whether you apply it from the foliage or you apply it from fertigation through the roots, or in some other way, in all the ways that are practices in agriculture. We're looking for those delivery systems. Obviously, you can't put something there that is toxic, that is not biodegradable. You can't really use things that maybe you were able to do in the past, but now you cannot. So this is the need in here. If you want to find more information, you'll see it on the website. Obviously, we are interested in something that is patentable, even if it doesn't have a patent now, because as a commercial company, it's going to be difficult for us to commercialize something that once we come out with this, anyone else can do the same. Cost effectiveness, I'm sure that those of you in this field know that something that works for pharma and it works perfectly, it's very difficult to do it in agriculture. So if you take liposomes, which is a great delivery system, you bring it down to agro, and agro just can't pay for this. So this is the major consideration here, not just because we want to save money, but because the market simply cannot accept something that is too expensive. Okay, so we're going to go to the next need. And by the way, after this session, we're going to have a Q&A, so you can ask questions, and also if you want, you can raise them in the chat. And hopefully, if your time will put it there, we will have also a survey that you can fill in some details. But if not, you can always contact us by email. So the next thing I want to speak about, the next need, is increased availability of phosphates to plants. Now, this is really just one example of perhaps a wider need that we would like to address, which is how do you improve the nutrient use efficiency? Because like in the example of nitrogen that I mentioned before, that not all of the nitrogen, or actually very little of the nitrogen, is taken up by the plant. This is also true for other nutrients. So phosphates, if you just apply them on the top of the soil, they have very low mobility in the soil. So they stay up there. If there's a big rain event, they can be washed away horizontally, and much of it doesn't reach the root zone. In addition to this, if you go to acidic or to alkaline soils, some of the phosphates are going to be attached, are going to be fixed by the soil particles, and that's it. They're gone. So you'll need some solutions to take them to unbind them from the particles. So we are looking at all those things that could increase the availability of phosphate to plants. So how can this happen? So one thing is you can solubilize this this part of the phosphate that is fixed to the soil, or you can prevent the fixing to start with. You can also somehow make the phosphate travel better through the soil and actually reach the root zone where most of it does not reach today. So these are some of the approaches that can be taken up. If it's cost effective, if it's something that works not only for some esoteric soil somewhere in the nowhere, if it's something that really can apply to a lot of conditions, then would be more than happy. And I mentioned in the beginning, we're leaders in PK fertilizers. We can certainly bring it to market with your innovation there. Okay. Next need is the plant stimulants, biostimulants. So this, for those of you who follow this, there's a lot of developments around biostimulants in the world, in Europe. Even the definition of biostimulant, it took many years until they reached the definition of what a biostimulant is. But now it's it's taking shape now, and it fits us very well, because biostimulants, first of all, it's not fertilizers. A fertilizer is not a biostimulant, but a biostimulant could be, let's say, a signaling molecule, that you introduce to the plant, and because it interferes with some metabolic cycle within the plant, or it interferes with the communication between the plant and the bacteria, or something else in there. So because it does this, it improves the yield, and this is what we're looking for. Now, many of the biostimulants address better resilience to biotic and abiotic stress. This actually we're not interested in, because I have to say that we are not in plant protection. Yeah, we do not make pesticides or insecticides or anything like this. Yeah, we're not in those agrochemicals. We are in the plant nutrition, but we see biostimulants as a sort of an area between fertilizers and pesticides. So it's sort of in the middle there, and we feel that we can go into this and really introduce some new products, and we have new products there. I should also mention, if I mentioned what we are not in, we are also not in any sort of genetically modified solution. This is, you know, as a commercial company, the main thing about this is that regulation is extremely hard, and you can, you know, Europe is a problem, etc. But also, I mean, it also ties to some other things. We're also not a seed company, so we don't really have anything to do with a genetically modified strain. Yeah. But if this is a biostimulant, so in fact, it can act in a very similar way to whatever genetic modification was targeting this trait. The biostimulant can do the same thing without going to the next generation of the plant, and that's what we're looking for. Those chemicals, those microbes that can have some temporary effect that is beneficial either on the yield, or maybe delay senescence, or that it, you know, improves the nutrient use efficiency. And yeah, so this fits us very well. Okay, so that's about this need. And the last thing I want to speak about is about our controlled release fertilizers. So this slide, first of all, just explains a bit about what a controlled release fertilizer is. Basically, you've got the nutrients, yeah, you've got salts, inorganic salts, which are the food of the plant, right, the nutrients that feed the plant. These are covered within a capsule. So this could be a resin, it could be some sort of a polymer. And then what happens, and this capsule is actually impermeable to water, but it is very slightly permeable to water vapor. So you put it in the soil, water vapor comes in, you get a very highly concentrated brine, and then the differences in the osmotic pressure cause the nutrients to be pushed out, to be diffused out. And the nice thing about it is that the release pattern is, you know, it's almost linear. So it provides the nutrient to the plant in a gradual way over time, and it could be months and months and months, and we have different products for this. So this is just a general explanation on this, because, you know, in a way, it's a perfect product, no problem with it. It's really, it answers the plant need perfectly. The one problem with it, I mean, actually there are two problems with it. One is that it's not, you know, dirt cheap like the commodity fertilizers, but that's our problem to solve. But the second problem is that generally those polymers are not biodegradable. And if you try to go to biodegradation, and this is our need in here, to go to biodegradation, then what you find is that you compromise the barrier properties. So, you know, this sort of balance between biodegradation and the barrier properties, which are affected by the coating thickness, and this affects cost, and everything is sort of affecting one another. So the challenge here is to somehow find an optimized solution that could still address this need for biodegradation. So there's very specific kind of conditions there: 25 degrees, 2 years, 95% of the 90 or 95, I forgot, of the material needs to biodegrade, meaning CO2 and water. Yeah, no no degradation products, and certainly not toxic products in there. So that's our challenge. Obviously, we have our own developments in-house. We're doing this, but we would love to collaborate with you. If you have some solutions in there, we'll jump on this if it's good. The problem is that many of the solutions are not good for our needs. Okay, so that's it. This is my email. We're going to have now Mickey Berson and Patricia Imas. So Dr. Patricia Imas. Mickey is responsible for innovative ag projects in RD&I. So all of those needs that I mentioned, he's day in, day out, he's dealing with projects about these. Patricia is the chief agronomist, and anything about plant nutrition, she's the right person to answer. So with this, I finished. This is the site that I mentioned before with all the needs, and I'm going to open it, Yotam, with your permission, to Q&A.
Thank you very much, Ziv. I asked some of you to please write questions on the chat. I didn't receive them, so we'll give a few minutes for all of you to try to write something. If it's more comfortable for you to write in Hebrew, it's also okay. Let's give them a few more minutes.
What we could also do, if there's no questions now, we could also change this session, put it in the end, so we can let people.
Yeah, so I think great advice. I think we will do it. Let's go next to our next step of the panel, and then we'll maybe choose something less short questions. Oh, we did receive some questions, you see.
Oh, okay. Yeah. Okay, so Yotam, if that's okay, I'll just read the question and then I'll refer them.
Yes, of course.
So where's the first question?
The several other solutions that you are taking.
Right.
Thinking about.
So Shubangi is asking. Hi, Shubangi. Okay, several of the solutions that you are thinking about could be possibly converted to service models, possibly with farmers with modern mobile apps. Are you already working on it? Okay, great question. Patricia, do you want to take this, the question about some service models, some of the things we do around this?
Yes, hello. Nice to see you, everyone. Actually, ICL has created a new division to deal with this subject. All the internet things, Internet of Things, how to deliver knowledge through the computer, through the cell phone. We are working very hard on this, and there are so many possibilities. Some solutions are now existing, like the farmer can take a phone and photograph the leaf of a plant, and then the phone will return answer if there is a nutrient deficiency, or what to apply, how to correct it. We are also gathering information from all research all around the world, trying to get an algorithm that may answer a lot of questions based on all the experience of so many years of research in plant nutrition. Everybody is on that, and also ICL. But of course, if you have any innovative solution or idea on this, we will be very glad to discuss with you.
Yeah, and maybe I'll just add, Shubangi, just because I know which company you work for. So we are also very much interested in any solution that also involves machine learning in this in the intersection of data, and there's a lot of data. I don't know if you know, but ICL purchased recently a Canadian company called Growers that deals with this intersection of data that comes from all sources, both from from mobile phones and from other sources around there. And so we are certainly looking at these solutions. Okay, so there's a question here: how do farmers select biostimulants that really work? There is so much hype about them. So Mickey, I think this is perfectly for you. You want to take it?
Yes, sure. Sorry, my video is not working, but can you repeat the question? Sorry, Ziv.
Yeah, so how do you select? You have so many biostimulants, so much hype about it. How do farmers select? What is the basis for criteria to selecting biostimulants?
Okay, first of all, unfortunately, I'm not familiar with that many biostimulants, not at least one that works very well. We do see better work when you have less
We can't hear you, Mickey.
Sorry, I have problems here. Anyhow, we see better work of biostimulant when the agriculture is not that extensive. Usually it works better. And we are doing a lot of works with a lot of researchers and institute and startups in order to find the right biostimulant to work with. Sorry, I didn't hear well the question. So Ziv, if I missed something, please let me understand.
No, maybe I'll just add that a part of the you're completely right that it's it's difficult to select biostimulants simply because the results that they show, the performance that they show, is sort of inconclusive in a way. And that's something that we put a lot of emphasis on how do you really validate this, and how do you not just sell snake oil basically, but sell actually something that works. And we invest a lot of money on analysis of field trial results. And so at least from our standpoint, we put a lot of efforts on validating those solutions. And this is what we present our customers, at least. So I think that this at least should be the basis for the criteria, even if it's not the criteria today.
Yeah, just to add in that we let the plant speak.
Right.
We tried many things, and we see whether it's working or not. And we learn also that in some condition it works better, of course, and in some less. And of course, the main target is to replace the use of either fertilizers, or it has to replace something in order to bring its benefit.
Okay, great. Okay, so we're just going to take one more question, and then we'll continue with this. Just to say, Michael Zviali, the food thing is going to be now, so you just need to wait a few more minutes. Focus on bioactives. So we're going to take this, I think, offline. Sensors. Okay, so sensors. Yeah, maybe I'll take this real quickly. So sensors are of limited interest to us. We're open to hear about this, but you should note that we are not going to produce sensors. And really, the only thing that sort of we can deal with is the data that comes out of it. So if you want to approach us on sensors, of course you're welcome to. But from the start, I'm telling you that we will not invest in the sensor technology itself. We may invest in the data that comes out of it and what to do with it. So your time, I'm bringing it back to you, and let's continue.
I think we have a few more minutes for one more question.
Oh, okay, perfect.
We have until 5:55, so it's
okay.
we have time.
Okay, until 55. Okay, so we have 4 more minutes. Hi, can you talk about the need for smaller decentralized ammonia production? Okay, great question. So maybe I'll take this one as well, just in a few words. The thing is that ammonia, to produce ammonia, you need to build a mega plant. And this, all those mega plants around the world, they take 1 to 2% of the world energy just to produce ammonia, and it pollutes by the CO2 that it creates. So, it's a hugely polluting, hugely energy consuming process. And I think that from, what was it, more than 100 years ago that the Haber-Bosch process was discovered, the people have been trying to find alternative ways. And now I think with the advances in green technologies in general, EV in specific, but also other technologies, there may be an opening. This, together with the possibility to have improved Haber-Bosch processes that perhaps use, lower temperatures, lower pressures. It seems like there are forces that kind of go one towards the other, and it seems like in the not so distant future, you will be able to have smaller devices, smaller plants that will be able to produce ammonia. Now, we are not that huge of a consumer for ammonia, but we are a consumer. And so we're looking for solutions like this. So I would say that the world needs it for sure. There's a huge need in the world. We are interested in this, but maybe we will not lead on this. But we are certainly interested in solutions, especially those solutions that are beyond a pilot stage. So I'm not so sure that we will invest in something that is early stage there, but we can, we'd be happy to speak about it with you, Paul. Yeah, okay, so I'll return it to you, Yotam, and let's continue.
Great, thank you. And I also mentioned that we received a lot of questions, so the ICL team will answer it through the live chat as well. So they will pick the questions that are feeling that are most, sorry for English, will help us to go through this webinar, but they will also answer you on live. I would like to welcome Dr. Haley, the VP Global R&D Phosphate Specialties from Germany, to speak.
Thank you, Yotam. Come on. I hope everybody could see my screen. Okay, good.
Yes, we can see it. Thank you.
Thank you. Thank you. Very warm welcome to all the participants. Good morning, good afternoon, and good evening. It's my pleasure to present a little bit what we are doing in the R&D of phosphate specialty. We have two presentations. I will give by myself the representation on the food innovation, what we are doing, what we're looking for. And Tony Gachui out of my team will show you a little bit the technical part and the technical needs on the material side. We are a truly global operation. We operate 6 different R&D centers around the world. It's mainly about application science of our products we produce. A little bit what we are doing. We are an ingredient supplier in the food industry for delivering food ingredients to produce industrial foods. We are organized by 5 different areas. That's beverages, meat, poultry, seafood, dairy, bakery, and more the vegan, vegetarian trends on the meat substitution. In that fields, we deliver certain functionalities. So if you think about the Coca-Cola, has a certain mouthfeel, a certain taste, that's part of the phosphoric acid inside. If you think about very tender, juicy barbecued meats, sometimes if it's marinated, it's also containing phosphates. Or if you look at things like muffin that has some fraction of baking powder, also the leavening acid is based on phosphates. And by our market context to all these food players we have, we also develop a lot around our market trends. That's somehow how we came to provide some vegan, vegetarian solutions for meat substitution that are not based at phosphates at all. We're doing that for a long time. If you look at the bottom of the page, you see a lot of brand names, Tari, Yoha. These brand names are more than 100 years in the market. So it's also a very mature business. And we are also interested always to look for innovation opportunities, to disrupt ourselves, to invent ourselves, and to write the story of the Yoha and Tari further on. How's that whole story working? We are part of the phosphate rock value chain of ICL. We are mining the rock in the upstream, we process it, produce phosphoric acid, and then there is a whole bunch of different phosphate salts to be produced out of this phosphoric acid. And the simplest business model we are running is taking our phosphate salts as basic ingredients and sell it to the huge big food companies. They know how to use it properly, so you don't have to teach a Nestle or Unilever how to use phosphates. But there is a lot of smaller, medium-sized players that are looking for solutions. And that's the second part where we develop integrated solutions, blends of different ingredients, means plant proteins, starches, hydrocolloids, spices, dairy proteins, and give our customers solutions and the chance to enter the market. So we enable startups to get into the market in the food space. I make you an example. If you go today to a supermarket, you see a lot of black cups, high protein milk, high protein yogurts. If you add a lot of protein to a milk product, you run into some stability issues. Somehow the water is separating, or if you heat it in a very short time period to sterilize it, then you have separation and sludges. And we provide the ingredients that this stays a nice, good tasting and well mouthfeel product to give you a good experience with the food. So in that regard, we deliver solutions for our food customers around texture and stability, helping to lower cost, increasing shelf life, and having also some convenience functions on the go, for instance. There's a big trend in the food industry. You see all these convenience shops, for instance, in China, to help our customers to get the right product ranges and to develop the right products. So we are more than a phosphate player, so we know a lot about the interaction of different ingredients and our phosphates. That's about what we are doing. A little bit how we see the world, what is the challenge and what is the evolution of food. And I think first of all, there are basic needs, and that's where it starts. I think the basic need is that you have sufficient food, that you have enough to eat. That's a basic need you have first to satisfy. The second need comes to having safe food, microbiologically safe food, reliable food, no food fraud, that you have safe food. The next category is that you have good and tasty food. Good and tasty means not necessarily healthy. Think of potato chips, very good and tasty, but for sure not healthy. So that's the first three steps of evolution. And what we see in the more, I would say, overfed markets where we are saturated is that we go more for the healthy trend, for functional food, food that is good for your health. And in the upper part of the pyramid, you see also the trend of having natural, simple, organic, clean label food. We play in all that domains, but to be frank and open, I think the phosphate part is playing in the lower bottom of the pyramid. So with phosphates, we are helping to use some side streams of food productions like cutoffs of cheese, like cutoffs of meat to make sausages, to make processed cheese, to make really nice, reliable products, nutritious products. But we are not playing so much in the healthy and functional category. So in that regard, that's why we are also evolved into the vegan and vegetarian base, what is quite trendy. If you look around, all these companies like Beyond Meat or Impossible Meat, what is a quite big trend in the Western world. So from that part, we have different strategies to address different needs of the world. So in that regard, we have the alternative proteins and low sodium toolbox based on the salts of the Dead Sea for the more mature saturated markets. But we go also for the emerging markets, because there's a lot of people around the world that don't have a cooling chain, they don't have a fridge at home, where transportation of food is very difficult. So there we go and help to preserve food, to make out of powders again liquid. You have a surplus of milk powders in the world. You could transport them very easily, but to make a good cream for your coffee out of that, or your tea, or to make a good milk out of the powder, that takes you a little bit of application science and some ingredients. So in that regard, ICL is playing on both sides of the need scale. And that's also how I want to structure what we are looking for. First of all, if you look on the core business of the phosphates, we see three different functions. We see a function of pH management and buffering. That gives you a lot of stability. Think of adding some lemon juice to a milk, you have automatically some sedimentation. If you would have that in a drink in a supermarket, you buy yourself a vanilla milk, you wouldn't like that to have some sludge in the bottom of the cup. So in that regard, pH management, buffering is very good for food stability. The other functionality phosphates have is ion sequestration. So they bind calcium and other ions like iron. And that helps us to liquefy cheese, that you get processed cheese in triangles, in slices for burgers, so that you could use some of the cut-offs, some of the residuals, the crumbles, and do some nice products out of it. That's one part of the ion sequestration. The other part of the ion sequestration is increasing the shelf life. Microbiology needs some essential minerals, metals, and if you bind them very firm to a phosphate, some of the species couldn't survive or grow as fast. They are not real preservatives, but they have a bacteriostatic benefit. Then you see the dispersion of particles, so that phosphates space somehow with these chains of phosphoric acid molecules. So these polymers, they space, for instance, protein fibers. So if you want to have a tender chicken on your barbecue, and put it into a phosphate containing marinade, you space the meat fibers and fibrils with a phosphate, and it adds some water. So if you have it a little bit too long on your grill, it's still good and juicy. So from that part, we help to disperse particles, proteins, could create food emulsions. A hot dog is nothing else than a food emulsion, and give stability and texture to certain products. And we are interested in that part of the world for any new applications that fit into that three basic properties. If you think about something where we maybe are not in confectionery or some other adjacent fields, we are highly interested. There's always a part where you have synergistic co-ingredients for phosphates that help to amplify the performance, that increase the yield of the food producer, give a better taste, give a smoother ice cream, whatever. So in that regard, we are always interested in synergistic co-ingredients for our phosphate solutions. That's the one part of the medal. The other part I want to show is somehow the natural label-friendly ingredients. So this is disrupting our own business. So it's somehow mimicking our functions we achieve with the phosphate, but with natural clean label ingredients. I built it like that I always brought the function and a little bit of example of some things that are already existing. And that would be, I have to look, here's some message coming in. Okay, that's good. I think here we are structured around different functions we need and some examples. So for instance, texture agents to increase water binding in processed food. So the example here is fibers. So if you want to have more water in a processed food, you add some fibers, this extracted from wheat, from citrus and bamboo. Very natural, very healthy also, is a good alternative. Also very expensive, by the way. Then you could add some ingredients that give you bite and succulence. What I mean is, if you have a hot dog, if it's cold, and hot, you want to have somehow a good texture. You don't want to have it mushy, and you don't want to have it too hard, too grainy. So there's a hot-cold behavior, and an example for this category is methylcellulose. Then we have the natural preservatives. That's an example where we have already extracts on the markets from herbs, from spices like rosemary, licorice. So in that regard, it's important to help also the food waste problem, because that's helping if you have longer shelf lives with natural ingredients. Then there are the natural chelators, what is very well known as citric acid, also since centuries. But we're also looking for new stuff in that field. So in that regard, also mimicking phosphates function. And the other one, if you think about leavening of dough, like muffins or sweet bakery, lemon cake, then we are looking also at natural leavening acids. So for instance, there are people that put lemon juice on a carrier, coat it with some ingredient, and then you have a retarded release of the acid function. So that's exactly similar functions we have in the phosphates, but accomplished by natural ingredients. And we are interested around exactly that space. So what could be there? What helps us to provide our customers in the Western world similar functionality, but with natural ingredients, disrupting our business. To summarize shortly what I showed you, I think it's one size fits none. So I think that's for me very important to state. So you have to understand food is very different from country to country, from region to region. And if you want to have good solutions for your customers, first of all, you have to understand where you are and what you want to provide there. So if you're in the Middle East, Africa, parts of Asia Pacific, that's different solutions you have to provide than if you're in the US side. So in that regard, we are providing both. And well, we are providing both sides of the solution. And we always try to follow our customers, understand our customers, and get new innovative solutions into the market that we have another 100 years to go. I'm now very open for questions. You could contact me also on the ICL email address, on the LinkedIn. And I brought also Satapan Srichivong with me, who is based in the moment in Japan and Osaka, or leader of front-end innovation, who's also happy to answer some questions. Thank you.
Okay, guys, this is your time to write us questions about the challenges in the food arena.
I think somebody asked us a question about food before. Maybe they can ask again by chat. Yeah.
Mm-hmm.
Yeah, okay.
We'll try to look.
But we can do the same thing. We can let people, think about the questions, and meanwhile go to the next session and go back to this if there are no, specific questions. I don't see at least a specific question right now.
Okay. Okay. So we'd like to try to invite Dr. Dioni, the global R&D and leader in St. Louis, USA.
Great, thank you. Good morning, good afternoon, good evening.
Good evening.
My name is Tony Gashui, and I'll be speaking to you from sunny Florida. And many of you might be wondering what I'm doing in Florida when I was just introduced as being in St. Louis. Well, I will tell you a little story. Let me first of all share my screen, and I will jump right into the presentation. So today actually marks a momentous day in the history of the United States because it is the first time we are launching man into space on a private spacecraft. And this is actually happening this afternoon if everything goes according to plan. As many of you know, let's see if I can find share my screen here. Just give me 1 second.
You are sharing, Tony. You are sharing.
Okay,
Just
yeah.
presentation back. Yeah.
Yep, okay. So as a native of St. Louis, I had the pleasure of actually meeting one of the astronauts who's going to be flying on the spaceship today. His name is Bob Benkin. He's actually a native of St. Louis. And it was just interesting to realize that we had a native St. Louis on a shuttle mission today, which, as I said earlier, it's the first in almost 9 years since we last launched space crew into the lower Earth orbit. So, as you can imagine, in this post-COVID-19 crisis, it's a little bit challenging to train as an astronaut when you have to have social distancing. So I'm not even sure how they plan on having social distancing inside of our tight crew aboard the shuttle, which is the Falcon 9. So my family and I drove down here to be able to at least witness this launch, which I think is going to be exciting. And like I said, we couldn't miss that for the world. My wife used to work at NASA, so we thought this would be a great opportunity for my kids who've never seen a shuttle launch to actually witness it and see somebody from St. Louis actually be on the first mission. So I'll be talking about what we do on the non-food phosphates. And these are phosphates very similar to what Dr. Heil mentioned that are used in food. But we're going to be focusing on the industrial applications. And I'll present some challenges, much like he presented challenges in the food space. So our business models are very similar. We produce what we call insoluble phosphate salts. These are salts made by reacting different types of cations with phosphoric acid, so calcium, magnesium, aluminum, potassium, etc. And we also produce what are called soluble phosphate salts. So these tend to be the sodium or potassium, so they're water soluble. And those go into different applications. We are selling what we call phosphoric acid as a raw material, but phosphoric acid is used in many different applications, not just as a raw material, but it's used also as a cleaning agent. It's used as an etchant. It's used as a catalyst. Then we sell polyphosphoric acid. Polyphosphoric acid is an inorganic polymer made by condensing phosphoric acid. And more recently, we've introduced a new technology into the market. It's based on a nanotechnology, very exciting, because this technology actually started from a startup company in Israel that we worked with about 3 years ago. So it's good to be able to show audiences such as yourself that technologies that start from startup companies can actually materialize into fully fledged commercial products. So this nanotechnology material is a product we're calling Scratch X. We just recently launched it again through our virtual platform. Scratch X is an additive that can be added to a wood coating. So if you think about your kitchen cabinets, your wood flooring, your wood furniture, a lot of that is coated. And most of the time it's coated with a clear varnish or clear coat. And you don't want to see scratches on that, especially if you have children or your pets. Scratches on your flooring or your cabinets is something you do not want to see. So we've recently introduced a mineral-based material, again, based on a nanotechnology that can be used to prevent scratches. So if you look at the middle of the screen, again, this is where our materials are produced, whether it's salt or acid, but we also do blends of different types of salts. We can combine potassium salts of different chain lengths. We can combine polyphosphates with phosphates. And we can also blend some of our salts with dispersants. So we produce what are called stabilized dispersions. And these dispersions can be in the form of, like I said, the Scratch X product that can be used to protect against scratches. The functionalities that we bring to the customer are shown in the big rectangular blue rectangle here, which is cleaning. So acids, as you can imagine, are very good at cleaning. Metal treatment, Anytime you want to protect metal, it's usually common to pre-treat the metal. So you take virgin steel or bare steel and you pre-treat it with phosphate. This not only helps to enhance the corrosion resistance of the steel, but it also helps to improve the adhesion of paint to that steel substrate. Dispersion, as Dr. Heil mentioned, phosphates are very good at dispersing particles. They're what we call anionic dispersants. So you're trying to disperse titanium dioxide, calcium carbonate, or other fillers. Phosphates or polyphosphates make very good dispersants. Chelation, we chelate things like magnesium and calcium, and that helps to soften water. So softening of water is a ubiquitous functionality that phosphates provide at very low cost. But we also have phosphates that help with things like stain blocking. What do I mean by stain blocking? Let's just say you have a wooden fence in your yard and you're trying to paint this wooden fence with a water-based paint. That wooden fence contains a lot of tannic acid because tannin is rich in wood. And tannic acid can bleed out of the wood into your paint and cause a discoloration. So we have additives in our portfolio that help to prevent the leaching or the staining of that tannic acid. We provide adhesion functionality with phosphates, and that's a huge area where we see some huge challenges, because anytime you're trying to improve adhesion, oftentimes it includes a lot of labor or a lot of prep work, and customers are looking to reduce the amount of time spent to prepare the substrate to improve adhesion. So if you look at the three areas of innovation, we have what we call a P2O5, or the phosphate-based business. It's about 80% of our business. Paints and coatings is about 10–15% of our business, and about the remaining 10 is about construction, where we sell a lot of additives into the construction market. And the construction market is cement, concrete, or gypsum, and in some cases asphalt as well. Okay, so these are some of the application areas where phosphates are used. And as I mentioned before, we're providing phosphates in different forms. So if you think about oil drilling, which is going on in the Gulf of Mexico here, you need to use phosphates to disperse the drilling muds. So phosphates are very unique in that aspect. If you think about oral care, so in your normal toothpaste that you're using, you'll find phosphates helping with removing stains from your teeth, but also preventing cavities. We sell a number of phosphates in this realm to companies like Colgate and Palmolive, etc. In metal treatment, again, we're very tied together with companies like Chemetall and Octite to make pretreatments for metal. In the cleaning area, we sell with companies like Diversey, which is a common household brand that you know for cleaning chemicals, whether it's industrial cleaners or household cleaners, you know, Procter & Gamble and so forth. Electronics, mining, and chemical manufacturing are two areas where phosphates are also commonly used. And when I talk about electronics, I'm talking about things like semiconductor etching, semiconductor wafer cleaning. This is actually a business that we've seen an uptick post-COVID-19 because, as you can imagine, with people staying home, everybody had to go and buy a computer. Computers are made of silicon chips or silicon wafers, and those silicon wafers have to be processed. And here we saw phosphoric acid as one of those necessary chemicals to produce silicon nitride or silicon wafers. Mining and chemical manufacturing are the two other areas where you'll see a lot of phosphates. Now I saved the best for last, and this is the area in the red box that you see where we have construction, paints and coatings, and asphalt. As three of the areas where we feel we have the highest need or highest unmet challenges, which we would like this ecosystem to be able to assist us. And let me jump into the first one, which is paints and coatings. So here we are supplying materials into four main paint applications. You can see in the middle of my screen, we have industrial paint. So this is paint that's applied to steel structures, infrastructure that is used for chemical processing. We have architectural paint. This is the paint you and I go and buy at the store. So when you go to the store to buy a house paint, this is architectural paint. You're going to use it on the interior of your house. And we have automotive paint that's used in your automotive shop, whether it's original equipment manufacturing, or it's paint that's going to be used if your car gets into an accident and it has to be repainted. And then you have marine paint, which is a huge growing market, especially with more and more ships being produced in Asia. So these are 4 areas where current products are being sold into. So some of the trends I would like to mention to the audience is we are looking at volatile organic compound free materials. So what does that mean? Customers are asking us to reduce the amount of volatile components in paint or to reduce the amount of heavy metals in paint. So heavy metals are things like zinc, copper, cadmium, tin, and lead. And you can imagine the products that work quite well tend to be heavy metal based. So if you think of the marine paint business, tin used to be the #1 antifoulant for marine coatings. Every shipbuilder was using TBT or tributyl tin to prevent the growth of biofilms or the growth of antifoulants on the ship hulls. Tin was soon replaced by copper. Copper was then regulated out, starting in California and Washington State, because copper has a problem with the ecosystem. It tends to diminish the growth of salmon, and salmon is one of those fish that are very common in the Pacific. Chrome-6 free. Chromate-6 is a material that's carcinogenic. Chrome-6 is heavily used in paint, particularly in aircraft paint. So anytime you want to protect aluminum assets, Chrome-6 was the corrosion inhibitor of choice, strontium chromate. And this, like I said, is carcinogenic. So industry has been looking to replace chromates for about 40 plus years. They still haven't found something that's as good as chromate in protecting aluminum. More newer is a biocide-free trend. So biocides, again, are used to preserve paint. If you think about the paint that you open up in your garage after, say, 6 months, you tend to see something in your paint that looks like bacteria. So that's what a biocide is in there for, is to prevent the growth of bacteria in house paint. House paint being mostly water-based. So they add biocides today to prevent that. We call that an in-can preservation. But customers are looking to replace biocides because a lot of people are sensitized to biocides. So when you apply paint in your house, there are people who have allergic reactions to the biocide in the film. APEs, or alkylphenol ethoxylates, or nonylphenol ethoxylates, are very well known surfactants. These have been shown to mimic estrogen in the human body, so customers are looking to replace these type of surfactants with APE and NPE-free materials. One-coat systems. Why would anybody want to put a one-coat system versus a 2-coat paint system versus a 3-coat? Well, it has a lot to do with reducing costs. Most people think of paint as just providing aesthetic functionality, but many times the paint provides, protection or helps build a barrier. So if they can get away with 1 coat, they prefer to put 1 coat. And many of you who painted your houses, anytime you buy a house paint, trust me, nobody wants to put 3 coats of paint. They want to put 1 coat of paint and be done. Okay. And then there's a trend towards moving from solvent or oil-based paint to water-based paint because of, again, the VOC issue. This is a growing trend and it continues to grow. And lastly, I would say easier to disperse. So when people are formulating paint, they're looking for materials that can be easily added to make that paint in the first place. So nobody wants to spend hours and hours trying to grind pigments, add colorants, add other types of functional additives. They want to be able to just quickly post-add those materials. So those are some of the key trends, and then you'll see some of these trends reflect themselves in some of the challenges we're facing. If we turn over to the construction business, where we're selling several additives today. So we sell additives into what we call asphalt or bitumen. Bitumen is used in paving. So you can see a photograph here of a road that's paved. Bitumen is used to enhance the protection of the road against wear and tear, so potholes. So we sell polyphosphoric acid to stiffen that bitumen resin and to improve the resin adhesion to the aggregate. So when you form a road, you're mixing bitumen with aggregate in order to form this paving material. So some of the key trends we see here is more and more folks are moving away from the carbon-based materials such as oils and asphalt, and they're looking at, can we use more recycled materials? Can we use polypropylene? Can we use polyethylene? Instead of taking these materials to a landfill, can we take these materials and add them into our paving materials to make better, more durable roads? So the use of recycled materials is quite huge. It's growing, particularly in the Western world, as we find new and better applications for plastic versus just, again, landfilling these materials. So weather resistance is a key trend. So when you think about shingles, and shingles may not be something common to other parts of the world, but shingles are used in the Americas to make roofing materials. So you see in the photograph in the middle, these are shingles being nailed onto a roof. And the shingles are actually an aggregate of materials. So you have granules, which is what you see on the outside. You've got the asphalt binder, which is right beneath that. And you have a fiberglass mat to hold everything together. Shingles have to be hail and rain resistant. Hail is common in the Midwest. We're in what we call the tornado alley. So a lot of people replace their shingles and roofs every 10 to 15 years because of hail damage. So how can we make our shingles more resistant to hail? So this is a clear challenge and an unmet need that we could use help with in terms of strengthening building materials. The picture you see on the far right is what we call our gypsum application. So gypsum is used, some people refer to this as plaster. Gypsum is used in construction of interiors for offices or homes. Here we're looking at ways we can improve the stiffening of that gypsum, sound dampening, or fire resistance of gypsum, because gypsum is mostly paper. It needs to be more fire resistant because fire codes are continually increasing in many jurisdictions. So we're looking for ideas to improve these type of products. So if I was to pinpoint some of the challenges we face in those two applications, paints and coatings and construction, I would say sustainability is perhaps the biggest one. Again, sustainability for us means, moving away from oil-based materials, things that are derived from oil, to greener technologies, so bio-based, moving away from solvent to water, use of more recycled materials. So think of, again, biofuel, so bioethanol, bio-based materials, and reducing the carbon footprint. So carbon footprint is anything that, causes an increase in the CO2 in the atmosphere. So if we can find materials that are more bio-friendly, this can help address some of the challenges we see in both paints and coatings and in construction. If you think about consumer safety, this is a big one. So consumer safety is perhaps the biggest challenge when it comes to our construction and paints and coatings business, because many customers don't want to use heavy metals. Heavy metals have a negative connotation, or they can be either toxic, like chromium, or lead, or they can be, hazardous to the environment. So they either kill marine life, like zinc does. So how do we remove heavy metals from paint formulations? How do we remove heavy metals from construction materials?
Tony, just to say that we'll need to finish soon. So yeah,
Okay.
I know that you're on the last slide there, but continue.
Yeah, and then the other two areas I would say where challenges are quite difficult is in cost. Again, cost reduction and ease of use. If we can reduce the number of raw materials that go into formulating paint, this would be a huge area to address challenges that customers are facing. And then ease of use, as I mentioned, how do we make materials that are more multifunctional? how do we bring materials to the customer that provide unique attributes where they can be simply post-added versus added through high energy means. And the faster return to service is an area, again, we're facing challenges. We want coatings that dry quickly. We want concrete that dries faster so that we can return that material to service quickly. So again, I highlighted the three areas again and the top challenges that we're facing in these industrial sectors. So if you could take a minute to look at that, I'm not going to read through the slides. I am joined today with two of my colleagues, Nathan Kofira, who's our Marketing Development Manager based in Chicago, and Michelle Bauer, a Senior Chemist, and they will be glad to join me in answering some of the questions that you might have. And I can also be reached on the LinkedIn site that I show here. So thank you very much, and we'll open it up for questions.
Okay, so I think what we will do now, we will move on for we will ask for Avi to speak, the Director of the Business Development. And right after that, we will give you some more time to reflect and think if there are more questions for us. And then we will stop for another section of questions to summarize before we're summarizing. Sorry, so Avi, you're welcome to present.
Yeah, thank you very much. Do you hear me?
Yes, we can. Thank you.
Excellent. And thank you, Ziv, is helping me with moving the presentation on. So I'm from Avi Ben Zvi from ICL Industrial Products. I'm the Director of Business Development. I'll present first our company. I try to be very brief. So we are 1.3 billion out of the 5.3 billion of the whole ICL. We have 11 manufacturing facilities worldwide. We're a global company with 1,050 employees and 3 R&D centers, 2 in Israel and 1 in the USA, in Tarrytown, New York. Our sales spread is quite evenly spread within the globe, although our home, let's say, market is close is Europe. But we are very strong in the Asia countries, mainly because of flame retardants we are selling, our flame retardant business, and then the rest, which is again not very far from the other areas we sell, is USA with 26%. Our portfolio, in fact, is most of our sales are based on bromine and bromine compounds, 68%. 14% are the specialty minerals we have, and then 18% are phosphorus-based compounds. And then the other way to look at it is 38% of our sales are flame retardant based. 14% again are the specialty minerals, and then the rest is 48% what we call industrial solutions, mostly are bromine based products, and later on I'll show this the application, so you can see the what does it mean, the industrial solutions. We have a global spread of our both sales offices, USA, St. Louis was mentioned before, USA, Amsterdam for the European countries, and then the Far East with several, Shanghai, Hong Kong, Tokyo, Seoul, Korea, and of course India. And the head office is here in Israel, and then we have the production facilities also spread USA, Europe, EU, and Asia, and of course main bromine compound facilities in Israel. As Ananta mentioned, so we are basically on the bromine side, we are coming out of the great synergism we have in the Dead Sea, and there we produce our bromine. And then most of our bromine is in fact is not being sold as such in the market, is just raw material for the bromine compounds production. mostly in Israel, and then we have the two other facilities, one in Netherlands and the other one in China, in the Shandong area, where we have bromine compounds production facilities. And again, the minority of our sales are going directly to customers. Phosphorus base, we are not back integrated into the yellow phosphorus, and our side is a bit different than the other side in the ICL. So we are starting from yellow phosphorus, but then we have the whole of the value chain, let's say, until production of the phosphorus compounds. Two facilities, one in Germany, Bitterfeld, and one in the USA in Gallipoli Ferry. And the rest is the mineral, specialty mineral plant, that also mostly coming from the Dead Sea. We are a leading global company. We are #1 in bromine capacity and bromine compounds plant. We are #1 in flame retardants, and out of it, the two biggest family are bromine and the phosphorus flame retardant, which for each we are #1. We are #1 in brominated biocides and #1 in clear brine fluids, which mostly is all of them are going for oil drilling, and then self-extinguishing hydraulic fluids, which phosphorus base for power plants, and magnesia for nutraceutical markets. So here is the spread of our the industries we serve and the applications. So electronics, construction, furniture, and automotive mostly are based on the flame retardants. We are selling, but we have also intermediates for food and pharma and agro. Oil and gas, as I mentioned before, is a big market we serve. Power plants, I will touch it immediately, and water treatment. And the reason, basically we are maybe so strong and we have such a spread is based on the bromine compound properties. So for instance, for the electronic, as I said, furniture, automotive, and the construction, so the flame retardant bring the quenching of radical in the gases phase. So this is the working mechanism for brominated flame retardant, and they are very, very efficient. Oil and gas, so there are two aspects. One is the biocidal properties, which I will touch immediately, and then the high density clear brine, and in fact it's coming also with perfect water solubility. The water treatment, so the biocides, in fact they have the oxidizing and polarizing active bond. This is the main property. Power plant, so here reaction with the metal, specifically is mercury. So in fact the power here is that in coal based power plants there is emission of mercury. The bromides, in fact, they are able to take out the element mercury and to turn it to salt, which is not being emitted to the atmosphere. And then intermediates, as I said, for food, pharma, and agro, they are basically based on various organic reactions, which in fact polarize carbon-bromine bond. And here, maybe to wrap up on this side, that the two slides which gives the main properties of bromine and bromine compounds. Some of them, because each and every gives a slightly different characteristic and property that is useful for certain applications. So the high density I mentioned, polar carbon bromine bond, oxidizing agent, high solubility, metal etching and metal leaching, in fact, ability to leach the metals, high refractive index. Bromine comparably can create high refractive index with different polymers, redox potential, radical quenching, and then diverse organic reaction, alkylation, addition, and substitutions. These are the main properties. The next slide. There are some additional properties. I will not touch everyone, but hydrophobicity definitely is important. Inhibition or co-catalyst. Carbon group transfer, CC bond formation, the radical formation quenching, UV curing, some application that basically using bromine compounds for 3D printing based on UV curing, for instance. It's a highly reactive intermediate, and well, polar carbon bond I mentioned before. Now, the bromine is part of the next slide, please, Ziv. Thank you. Bromine is part of the halogen family, and what is the difference or differentiation between bromine and the other halogens? So compared to chlorine, bromine is better as a higher boiling point, less volatility, less corrosivity. It has easier handling, easier recycling. And compared to the iodine, bromine is much cheaper and more abundant than iodine. It's in fact 10 times on one end cheaper than iodine, and then the availability of bromine is 10 times more than the size of the market, or the available product is 10 times more than iodine. And then in general, bromine is less reactive in organic synthesis, thus allows better unique selectivity and the mechanism, and it's a better living group in organic synthesis. So all these characteristics, in fact, and in fact what we are coming to the audience is ideas that might use these unique properties for areas that might be of use. I'll touch it immediately. These are a few examples of development and a few evolving trends that we have already, our innovation is already handling, let's say. So the autonomous vehicles and electric vehicles, we have flame retardants that are very useful for the electric vehicles. Biocides, mentioned the post-corona, I think the autonomous cars, and in fact all public transportation on top of that, the disinfection biocidal products, I think they will come to a very, very high importance. So we cannot really predict exactly what will be, but I think it's very, very logical that all elements in public transportations will use such products. Regarding renewable technology and energy storage, so here we are very active also. We have some activity in the energy storage. We are active with global or companies, worldwide companies on the energy storage based on bromine technology, either hydrobromic acid or zinc bromide. There are bromine-based batteries, so, and there is some activity in the energy storage for telecom. And the last, in this slide is the last example. So the new evolving Internet of Things and big data. So we have special unique offering as flame retardant for PCBs and a very new developed product for the 5G new network. Okay, so a summary and takeaway. So as I mentioned, bromine-based products are playing a very significant role in many industries and the application, utilizing the diverse properties. And we are following the evolving trends and developments to come up with new solutions to the market. And then what we come to you as audience. Ziv, one click, please. Thank you. So from you, we are really looking for any new idea that might support us with the new evolving trends. So you saw what is on one end the application in our activity and new activity and the evolving trends. So any new idea from your side, and on the other hand, how can we support you if you have any new development or unmet needs that now looking at the bromine-based chemistries and properties, you see, okay, this might bring some solution of values to your world of activities, developments, or unmet needs. So in fact, this with this we finish. I will another click, Ziv, please. Okay, so from here we move to the expert panels, which are our head of organic chemistry, Dr. David Feldman, our head of inorganic chemistry at ICLIP, Dr. Eyal Barnea, Dr. Merav Abekassis, which is the head of the formulation lab, and Mr. Ilan Behar, which is part of the business development team, is in charge of the energy in the business development. Merav, I would really appreciate if you can help if reading or gathering the questions coming up from the chat. So we see how to address them.
Yeah, as you said, I wrote in the chat as well, we're finalizing our webinar. So this is your few moments that you can still try to write some few questions. Until the questions will be coming up, I would like to get the opportunity, because we know some students also joined. Can we ask the question, or I can ask on their behalf, can you give us some tips how we can start our journey through innovation, through the industries of food and environment, food and agriculture, of course. Until we have some questions, it will be a pleasure to get the answer.
Anto, do you want to take this?
No, but Andreas and you probably. Why don't you do it? Yeah.
Andreas, you take it. I don't know. I mean, how can I don't feel that I'm in a position to consult you. You need to find your own way.
No, but I think that is important. But I think you heard at least what we are trying to do, and I think if there are ideas, startup type ideas, or thought processes that we can help in terms of mentoring, is an opportunity for us. And we learn from that also, because we learn from fresh ideas from students, and that is very useful. I think it's a mutually win-win situation, I think. So I think we could provide opportunities for mentoring. We can provide, again, the channel to market in some cases, and also and capabilities like the labs in Haifa and in Ladenburg, and we have the access in at different areas to collaborate if it makes sense for both of us. Again, Andreas, you can add to it also.
Absolutely. I think we know what we know. We are in some parts a very mature business. We learn from our customers, but and also see consumer trends. So we have a high connection to markets and consumers somehow. But I think on the technology side, what is happening there, identifying new ingredients, identifying new ferments, extracts, new spaces, that's always something exciting to learn. And that's more happening on the institutes and the startups at the universities. And I think we are a quite hands-on company to work with, I think.
If I may add, the main suggestion to students or anyone is reach out. We have in the presentation all the emails of our experts on our panels, and we are ready to hear every idea that comes up, and reach out.
We will certainly do. Thank you for the answer. So it's 10 to 7. I would like to have the conclusion remarks. Ananta, we would like to finish the webinar.
Yeah, thank you again. I started with thanking you, Yotam, and Itai for organizing this. I really appreciate this opportunity. I think I enjoyed it a lot. I learned, also something from our presentations. I thank the presenters from ICL. I think it was very nice, well managed. Of course, Dr. Amnon, the head of Hugie, I think I'd like, if he's around to also conclude it. I think really appreciate it. As we said, it is a starting process. We are learning, and again, we have started our innovation journey a few years ago, and we already have established partnerships. We've taken products to market, as Tony mentioned, as Andreas mentioned, as Avi mentioned, and Ziv also. So I think we are looking to expand and learn from the ecosystem. So really appreciate this opportunity, I think.
Steve, you want to close to finish up?
No, nothing to add. Just
Okay,
we look
so
forward to answering your question offline, whatever we didn't answer up until now.
great. So I want to thank you all once again. I want to thank you, Ananta, and all the presenters that we had to the opportunity and the pleasure to host you in our webinar. I want to thank the ICL organization as a whole. I see a lot of opportunities here from our side, from the university, from Huji Innovator as well. And I will definitely reach out as you serve the question, so we will definitely do it. And thank you all. Have a great weekend. And now tomorrow we're celebrating in Israel Shavuot. So to everyone, Chag Shavuot Sameach, happy holiday. Have a great weekend. Thank you all.
Okay, Chag Sameach, Shabbat Shalom.
Thank you.
Thank you.
Thank you.
Thank you.
Bye. Chag Sameach.